Most people think AI chatbots have actual memory, but behind the scenes, most systems are using a brute force trick. They simply copy and paste your previous chat history into every new prompt you send. This works fine for a few minutes, but eventually that massive block of text hits the system's hard limit for processing data. When the file gets too big, the older text gets chopped off, and the AI suffers sudden amnesia about who you are. True artificial memory requires a different approach. Instead of treating your life as one overgrown text file, memory has to be engineered as a system that separates raw conversation from behavioral context. We call this the four-layer brain. It divides information into distinct storage lanes: a short-term workspace for your active transcript, long-term searchable vectors for past chats, structured facts for stable details about you, and a behavioral profile that tracks your personality. This separation ensures that thousands of past messages don't consume the processing power needed to generate a single, coherent reply. To see how this architecture works in practice, let's look at the live hot path. This process starts the exact millisecond you hit send on a new message. Before the AI even generates a reply, your text passes through a deterministic filter. This instantly scans your message for rigid data points, things like your preferred name, a strict rule, or the specific project you are currently working on. These isolated facts are immediately plucked out and stored in a dedicated user memory database. Doing this instantly is crucial. If the system waited until the end of the session to process your chat, it would spend the rest of the current conversation ignoring the preference you just stated. And because this relies on hard-coded extraction rules rather than calling out to a massive cloud model, it acts as a reliable failsafe. If the main language model temporarily goes down, your core commands and preferences are still securely captured. When you update a detail, like changing a project deadline, the system recognizes the existing fact and simply refreshes its timestamp, rather than creating a duplicate entry. This rapid, live processing guarantees the AI adapts its very next sentence to your newly stated preference, without needing to restart the session. Conversations generate a massive volume of data that goes beyond simple preference labels, so when you explicitly start a new topic, or if the chat goes quiet for a few hours, a deeper processing trigger engages. The raw transcript is moved out of your active window and into a background loop. This ensures your live chat interface remains responsive, while the heavy computational work happens out of sight. This archive transcript is then split up. The first processing path takes chunks of your conversation and mathematically embeds them into searchable vectors, allowing the system to recall exact phrasing from a chat you had 6 months ago. The second path handles relationship mapping by extracting a knowledge graph. This connects distinct subjects and objects, linking you to your coworker to a specific project, and that project to a deadline. This transforms raw text into a structure where facts and relationships are immediately accessible to the model. But pulling data out of memory requires knowing exactly what kind of answer you are looking for, and human questions are often ambiguous. If you ask, "What was the name of that software package we used last week?" the request is purely factual. The system accurately routes this straight into standard semantic search to find the exact noun. But imagine you send a message saying, "I feel like everyone is ignoring my input on this." A standard keyword search might pull up old conversations containing the word input or ignoring, which leads to a clinically cold response. To fix this, Synapse uses affect tags. When a memory is stored, the system logs the event itself while also recording the emotional shape of the conversation, tracking the overall mood, the underlying tension, and the user-specific need. An emotionally charged message forces the system to calculate an affect match score. Instead of hunting for raw keyword overlaps, it seeks out past memories with similar emotional tags. Mapping these emotional shapes ensures the AI retrieves the facts along with the right tone, getting it the context required to comfort, encourage, or challenge you at the right time. All of this gathered data, the facts, the graph connections, the emotional states, flows into a final behavioral engine called the SBS layer. The SBS layer translates these data points into behavioral rules. It updates vocabulary, tone, and pacing based on your history and mood. Then it compiles a custom prompt, pulling the dynamic persona, graph context, and static rules into one cohesive set of instructions. Crucially, this final assembly includes a set of guardrails. The system explicitly instructs the language model to rely exclusively on the retrieved facts placed in front of it, preventing the AI from inventing fake details. Building a personal AI requires departing from the brute force chat log. It takes a layered architecture to maintain accuracy